Hello, good afternoon, dear students. Uh, Now the time is 2:31. Let's wait 2 more minutes. The remaining people will join. After that, I will start the session. Meanwhile, you can send your attendance to your CR. He or she will forward to me. Yeah, good afternoon, dear students. Now we'll start the session. Almost now 46 students are joined. Hope my voice is audible. You all people are on mute. Myself only on mute. So if you have any doubts, please use your chat box. My voice is audible. If yes, mention chat box. Yes. Okay, dear students, hope my voice is audible. Let's start the session. Right, I hope my screen is visible to you. So in the last class, we started the pharmacognosy of enzymes and protein drugs. Out of this enzymes and protein drugs, we discussed the proteolytic enzymes, that is papain, bromelain, serratiopeptidase, urokinase, streptokinase, and pepsin. All these drugs are discussed in the last class. Only left over is the proteins, that is the gelatin and the casein. Now, today I'm going to discuss about these two drugs, gelatin and casein. So these two drugs, gelatin and casein, these two are comes under proteins. See, first one is a gelatin. See the synonym. The synonym gel foam, puragel, gelatinum. These are the generalized synonyms for the gelatin. Gelatin is generally a animal-based protein, so it's very fine, widely used in preparation of capsules. Hard gelatin capsules and soft gelatin capsule. Before going to explain these gelatin and casein, these two are belongs to the proteinous in nature. So what do you mean by a protein? I will give the definition. So a proteins are a long chain molecules. They having those long chains are made up of amino acid residues, right? So simply proteins are a long chain residuals of amino acids. So they have a variety of functions in the human beings and as well as in animals. So that as well as therapeutic and general clinical applications are there. So this is in general a brief about this protein. So under this pharmacognosy of proteins, there will be two drugs, gelatin and casein. So gelatin is a widely acceptable protein because this is only raw material that can be available for manufacturing of capsules, gelatin capsules, right? So apart from that, it's also used in different bacteriological culture mediums also. So that gelatin is a very important one for further study. So synonyms: gelatin, gel foam, puragel, and gelatinum. Coming to the biological source, I already told gelatin is a animal based one. So it is a protein derivative obtained by evaporating an aqueous extract made from bones, skins, and tendons of various domestic animals. Some important sources like ox. So ox is ox and sheep. These are the only two widely used sources for the production of gelatin, ox and sheep. So apart from these ox and sheep, there are some other. What are the domestic animals? Generally, we found so from the bones and tendons and ligaments are also this gelatin is prepared. So it is a animal based protein. Then coming to the characteristics, gelatin occurs as a colorless or slightly yellow, transparent, brittle, practically odorless, tasteless. It occurs as a sheet-like flakes or coarse granular powder. In water, it swells and absorbs about 5 to 10 times of its weight of water to form a gel in solutions below 35 to 40 degrees centigrade. It is insoluble in cold water and organic solvents and soluble in hot water, glycerol, acetic acid, and it is a amphoteric in nature. The quality of gelatin is determined on the basis of its gel strength. This gel strength is called as a Bloom strength. In generally, the quality, how we can decide. So here, there will be one parameter to judge the quality of a gelatin. That quality of gelatin is can be determined by using a one parameter called Bloom strength. Remember, ఇది మీకు సుటిక్స్ లో కూడా వస్తుంది ఫార్మస్యూటిక్స్ లో ఈ బ్లూమ్ స్ట్రెంత్ ఈజ్ ఏ ఫార్మస్యూటికల్ పారామీటర్ టు జడ్జ్ ద క్వాలిటీ ఆఫ్ ఏ gelatin. So that can be measured with the help of a one physical meter that is called a Bloom gelometer. By using this one, we can measure the gel strength can be measured. What is the gel strength? It is used in the preparation of suppositories, pessaries, and other capsules preparations. Commercially, there will be two types of gelatins are available: gelatin A and gelatin B. And type A has an isoelectric point between pH 7 and 9, whereas type B has an isoelectric point between 4.7 and 5, and it is usually anionic mixture. Gelatin is colored with a certified color of for manufacturing of capsules or for coating of tablets. See, so not only for preparation of suppositories and pessaries, so the gelatin is also used for making of gelatin capsules and also used as a coating material on the tablets. Then coming to the chemical constituents, gelatin, it is a protein, animal based protein. It mainly contains a gluten, which on hydrolysis gives a mixture of amino acids. The appropriate amino acid contents of this are glycine, alanine, valine, leucine, isoleucine, cysteine, cysteine, methionine, tyrosine, aspartic acid, glutamic acid, arginine, lysine, and histidine. So you no need to write all these amino acids. Just you should mention gelatin is mainly contain a protein gluten, so which is on hydrolysis gives a mixture of different amino acids that is sufficient to you. So out of this, the major one is a glycine. Glycine is amino acid. So apart from that, it is a nutritionally important. Nutritionally, gelatin is an incomplete protein lacking tryptophan. That is why it is not lack of this tryptophan. It is incomplete protein. The gelatinizing compound, it is known as a chondrin, and the adhesive nature of this gelatin is due to the presence of gluten. So because why they can it can be used in the preparation of capsules b means because of this present having of a adhesive nature. This adhesive nature is due to the presence of a protein gluten. Then coming to the identification test for gelatin. So the first widely accepted identification test for this protein, this gelatin, is a biuret reaction or biuret test. Biuret test. The alkaline solution of a protein, to this we have to add a dilute solution of copper sulfate. A red or violet color is formed with the peptides containing at least two peptide linkages. A dipeptide does not give this test. So it's a simple test for the identification of a protein. So because it is a gelatin is a protein, so it also same responded. A violet or red color is responded. Then second one is a xanthoprotic reaction or xanthoprotic test. So generally the proteins forms a yellow color when warmed with a concentrated nitric acid. The same concept here is also applicable. This color becomes orange when the solution is made alkaline. Same. So is a generalized protein test that can be applicable. Third one is also same, Milan's reagent or Milan's reaction or Milan's test. So the Milan's reagent, nothing but a mercuric nitrate nitric acid containing a traces of nitrous acid, and is usually gives a white precipitate on addition of a protein. So which turns red on heating. So it is a simple another identification test for a protein. So this is also applicable for the identification of this gelatin. That is biuret test as well as xanthoprotic reaction and Milan's test. Now we'll see the uses. So far, we already discussed the different uses. The gelatin that can be used in the preparation of suppositories, pessaries, used in the preparation of capsules, both the soft gelatin capsules and hard gelatin capsules, and also as a coating material for the tablets. This is a generalized uses. Now we'll see the specific uses. It can be used to prepare the pastries, paste, suppositories, capsules, pill coatings, gelatin sponge. It is also used as a suspending agent, tablet binding agent, coating agent, and also as a stabilizer. Because of this thickening properties, it's also used as a thickener, right? It is also used in the manufacturing rubber substitute, adhesives, cements, and printing inks, and also used in plastic compounds, artificial silk, photographic plates, and films, light filters for mercury lamps, clarifying agent, hectographic matters, sizing papers, and textiles. There will be a number of unlimited uses is there because of this adhesive properties as well as these gelatinizing properties, so that it can be a multi-purpose. In pharmaceuticals, we have only remember. In pharmaceutical, it can be used in the preparation of suppositories, pessaries, pills as a tablet coating material, and also for preparation of soft gelatin capsules and hard gelatin capsules. Those are the uses in related to pharmacy. Then coming to the next protein, casein. So I think uh, casein is a milk-based protein. Casein, it is a proteolytic enzyme obtained from the stomachs of cows. It is extracted from the proteins of the milk. In the milk, casein is structured in voluminous globules. These globules are mainly responsible for the white color of the milk. According to the various species, the casein amount within the total proteins of the milk varies. See, so because it can be present in the milk, so the amount of casein that may be varied based upon the species. So remember, exactly we doesn't it not possible to quantitatively to measure the casein content in a milk, so because it can be varied from a species to the species. It's a milk based protein. In generally, the casein content of milk about 80% is in general, but species to species is vary. The principal casein fractions are alpha S1 and alpha S2 casein, beta casein, and kappa casein. The distinguishing property of all caseins is their low solubility at pH 4.6. The common compositional factor is that the caseins are conjugated proteins. See, these are the conjugated proteins, most with a phosphate groups esterified to serine residues. These phosphate groups are important to the structure of the casein micelle. Calcium binding by the individual caseins are proportional to the phosphate content. Coming to the casein characteristic, because it's a isoelectric point of casein is a 4.6, because of the its low solubility, yeah, it's having a isoelectric point of 4.6. The purified protein is water insoluble, while it is also insoluble in neutral salt solution. It is readily dispersible in dilute alkalis and in salt solutions such as sodium oxalate and sodium acetate. Casein does not coagulate on heating. It is precipitated by acids and by proteolytic enzyme. In generally, majority of the proteins sometimes they coagulate on heating, but here in case of casein, it does not coagulate on heating. This is a very much important property of the casein, and it is also precipitated by acids as well as also by the proteolytic enzyme. See the chemical constants, because I already told the casein content is varied from species to species in the milk. However, the general content of casein is 80%. So the milk contains about 80% of the casein content. So the major constants of a casein are alpha S1 and alpha S2 caseins, beta casein, kappa casein. So totally three types: alpha, beta, kappa. In alpha, there will be two types: S1 and S2, beta casein and kappa casein. These caseins are conjugated proteins. So is another important point I already discussed in the previous part. So these are the conjugated proteins. So to which they are conjugated phosphate groups. So these caseins are conjugated proteins with phosphate groups which are esterified into serine residues. They have and also they have a low solubility pH of 4.6. Then coming to the uses, it is used in the manufacturing of binders, adhesives, protective coatings, plastics, such as for knife handles and knitting needles. It is also used for manufacturing of fabrics, food additives, and many other products. It is commonly used by bodybuilders as a slow digesting source of amino acids. There is a growing evidence that the casein may be addictive for some individuals, particularly those on the autism spectrum are having schizophrenia. However, it can be used with a caution. So these are the some of the uses of a casein. So these are the two drugs were left over for the last class. Protein, that is gelatin and casein. So by these two drugs, we can conclude the chapter enzymes and protein drugs, pharmacognosy of enzymes and protein drugs. Just to see the outline, what are the proteolytic enzymes and proteins? The proteolytic enzymes are, in your syllabus, they're given papain, bromelain, serratiopeptidase, urokinase, streptokinase, and pepsin. These are the six enzymes they can be given in our syllabus. In case of proteins, so gelatin and casein. So before going to this enzymes, I already completed. I given some introduction to the enzymes. That is a definition and a classification. But in case of proteins, I'm not much given the introductory definitions to this protein. I think you people are very well known these proteins, right? The proteins are very long chain residue of amino acids, right? So they have a variety of functions in the human body. They can be formed from ribosomes, right? So all the proteins generally formed from a ribosome. So like such definitions, and apart from that, the generalized identification test I already discussed in gelatin, right? So xanthoprotic reaction, Milan's reagent, biuret test, all these are the generalized identification test for a proteins. So you people are much concentrated on these two drugs, gelatin and casein. So So now I'm stopping my screen sharing. I think only 58 members are available for today class. I don't know why in so many absentees. Okay. So all your attendance, please give out your CR. Okay. CR Anasuya, you can collect the attendance from your friends, and finally you can forward to me. Hope my voice is audible. If you have any doubts, your chat box is enabled. Please mention if you have any doubts. Hope మీ అందరికి తెలిసి ఉంటుందమ్మా మేబీ జూన్ ఫస్ట్ ఆన్వర్డ్స్ యూ పీపుల్ గాట్ ద హాలిడేస్ సమ్మర్ హాలిడేస్ మేబీ 10 or 15 days soon you get the circular for that. I'm not sure, but I'm getting some unauthorized informative. Anyway, you people get the holidays again. Right. Okay, dear students, now the session is very quickly ended because of only two drugs. The next time onwards, we will see the next primary metabolites. Now onwards, we can disperse. Have a great day. Thank you. Happy weekend. If you have any doubts, please mention chat box. Otherwise, okay, fine. You can leave the meeting.